This module introduces the use of structured text to construct conditional logic statements. In this section, we will introduce the behavior of conditional instructions, demonstrate the coding of an if-then instruction, and demonstrate the coding of a case statement. This lesson will introduce the general concept of conditional instructions and how to author them using structured text. Instructions tell the project what to do based on the result from evaluation of the given expressions. There are basically three categories of instructions in structured text: conditional, iterative, and execution control. In this set of lessons, we'll examine the conditional instructions. There are two conditional instructions. If the condition is true, do this. In case an integer variable has a value of, do this. These are categorized as conditional because they each have a condition or set of conditions that must be met in order to trigger the execution of various instructions. Each is a way of packaging a group of instructions into a compact structured text statement. Let's examine them in order. This lesson will look specifically at the structured text syntax of an if-then statement. Here is the syntax for the if statement. The else-if and else parts in red braces are optional. It is perfectly legitimate to have an if instruction that has only one condition. The order of evaluation of the conditions is top to bottom. If the Boolean condition 1 returns true, then only the if instructions are executed and none other. Otherwise, the Boolean expressions, beginning with Boolean condition 2, are evaluated one after the other until one of the expressions returns true. Then, only those instructions after this Boolean expression and before the next else or else if are executed. If none of the Boolean expressions evaluates true, then only the else instructions are executed. Realize that as soon as an if or else if condition evaluates true and its associated instructions are executed, the runtime jumps to the end if command and ignores all remaining conditions and instructions. We'll see in the if demo that follows that this has important execution implications that must be considered. Here is an example of an if-then statement that determines whether a value is counted up or down. If the variable countUp is true, then the variable count is incremented by 1. Else if the variable countDown is true and count is greater than 0, then the variable count is decremented by 1. A Boolean flag is also manipulated to show the behavior of the else option. Remember, the only required syntax is the if, then, and if portions of the statement. It is not necessary to include an else if or an else section. The following video demonstrates the syntax of a complete if, then, else if, else, and if statement. In order to demonstrate the if statement, I have created this simple little project called If Example, and it has a single device, single application, single program organization unit, PLC_PRG, written in structured text, and the structured text happens to be empty right now because we haven't created anything. There's also a visualization that we'll look at later when we want to prove out that this if statement works the way we want it to. So let's go ahead in our PLC_PRG and demonstrate some things about the if statement. The first thing is we could create the variables up top if we want, but we've selected the option of creating the variables as we go. So let's begin by typing I. Uppercase or lowercase, doesn't matter. The autocomplete says, oh, this must be an if statement. We go ahead and say enter. It gives us the if statement. We hit enter again. It completes it for us. Now the software recognizes that the only obligatory parts of an if statement are if and end if. You're not obliged to have a else if statement or an else statement. You can simply have if this condition, then execute this instruction. And that's what we're going to do to begin with. We're going to come up to the if. I'm going to double tab because I want everything to be lined up. Now I'm going to create the if condition. What I want my if statement to do is, according to a couple of different conditions, I'm going to have a variable called count, and I either want to add to count or I want to subtract from count. I want to either decrement it by 1 or I want to increment it by 1. And so the first condition is going to be called countUp, and it's going to be a Boolean condition that says, if countUp is true, I want you to start adding 1 to count. So we'll create that variable, countUp, and so we're just typing that in here. Now, what's interesting is there's a couple of directions I could go from right here. I'm creating the condition. This is a variable, count up, and I want it to be bool, but I haven't told the software that yet. But I'm going to tell it if count up is equal to true. So let's just type in true, and then I'm going to come in here and say then. If I do lowercase, doesn't matter. The auto format's going to correct that. So pausing right here, as soon as I hit enter, the software is going to say, well, you've declared a variable, or you're about to declare a variable called count up. You're using it anyway, and I don't see it declared anywhere, so I'll auto declare it for you. So it's going to do that. But what's interesting is looking at the syntax here, I'd like to know what it's going to type it as. Is it going to type it as a bool, as an integer? What kind of variable is it going to create, and how does it know that? Well, it turns out it doesn't really know that. So when we click on there or hit enter, it's going to say, well, I recognize there's a new variable being used in the body of the POU here. It's called count up. And look at it, try to name it an integer. You might find that inexcusable because you might say, well, any if statement has to evaluate to a Boolean value. You can't sort of satisfy an if statement. You either satisfy it or you don't. It either is true or it's false. So shouldn't this be a bool? Well, not necessarily. I could have a Boolean condition which says my integer variable is equal to 6. Okay, as long as integer variable is equal to 6, then do this. So that's a Boolean condition based on an integer variable. So it really doesn't know. It is kind of odd that when I assign it a value of true, which would imply that I'm expecting this to be a Boolean value, it doesn't pick up on that. So we can help it out. We just say, well, I really did mean for this to be a bool. And so it declares it and says, oh, count up is a Boolean value, and if it is true, then do something. Before we just accept that, I want to go ahead and delete this variable that we just created. Okay, so I'll just go ahead and delete it. And I'm also going to delete the remainder of this if condition statement that I did here. And I'm going to show you a different way to do that. What we just did was an explicit use of a variable by saying, I am explicitly telling you that if count up is true, then do this. Well, what if I just typed count up? If count up, then. Well, what does the software think of that? Well, as soon as I hit enter here, it's going to say, oh, there again, I don't know what count up is, but look at what it assumed it was this time. It assumed it was a Boolean variable because the software apparently knows, oh, this is the only thing between the if and then statement. That better evaluate to be a Boolean result, or this is an invalid if condition. So it was able to correctly identify that as a Boolean value. So that demonstrates two things: how the auto-declare thinks, if you will, in quotes, and also the fact that you can implicitly use this variable, and if you do that, it'll just assume that what you mean if count up equal to true. So this means the same thing. If count up then is essentially saying if count up is a 1 or if count up is a true, then go ahead and do this statement. Well, what is it that I'm going to do? Well, let's come in and say, I have another variable, and I talked about this. Count is the variable that I want to either increment or decrement, depending on whether I use count up or count down. So this will expose another sort of idiosyncrasy of the autocomplete. So I'm going to go count, because that's the variable I want. But look what the autocomplete is trying to do. It's trying to give me count up, because the names are so similar. If I didn't pay attention and just hit enter, or not enter, but hit the space right now as though I was going to say count shall be equal to count plus 1. If I hit the space key, you see how the autocomplete went ahead and gave me the variable it already had? Well, that's incorrect. Okay, so I delete that. The way you prevent that is if you've gone ahead and typed count, because that's the variable you want it to declare, and you see that it's trying to pick something that's close to that. And you do sort of have to keep your eye on this, because if you're just clocking along, typing the stuff out and hitting enter, you may let it pick a variable that you don't intend. To make it stop doing that, simply come up and click where the cursor is here, and the autocomplete dialog box will go away, and it'll understand, okay, I get you don't want my help, so I'll let you do it on your own. So now we say count shall be equal to count, and it's going to try to do it again, okay, count plus 1. So again, just click the cursor up here to prevent it from using count up. Count shall be equal to count plus 1, okay? And then our obligatory semicolon. So that's our statement this is the instruction for this condition. Now, it also has told us, well, you know, you just declared a new variable that I don't know. And so this time it got it partly right, because it says if you're going to add 1 to it, it must at least be an integer. And what it doesn't know, because we haven't told it, is that we actually want it to be a double integer. Okay. So that is the completion of our first if statement. And this is a completely valid completed if statement. It's if count up, then count shall be equal to count plus 1. And that's the only part that we need for a valid if statement. And if count up isn't true, then don't do anything. Now, one more thing I want to tell you. What if we wanted to very specifically, we wanted to do something if count up was a 0? Okay, well, we could say count up shall be equal to false, or count up, or not, shall be, count up equals false, or count up equals 0. If count up equals false, we could come and say that. Then, okay, or the other thing we could do is say, you delete this, and we can say if not count. Okay, so that says exactly the same thing. So if count or if not count is a way of using a variable, a Boolean variable, without having to explicitly sign the value that you're looking for. So that's the completion of our first if statement. But we already agreed that we want our if statement to do more than just count up when it sees the count up variable go true. So we'll come down here. And now we're going to type an else if. If this, do this. Else, if this, do something else. So as soon as we type ELSI, the software autocomplete says, oh, you must want an else if portion for the if. So we say enter, tab. And now we're going to create another variable called count down. So count down. And if count, or else if count down. Now, that's all we need. We need a then, and then we can hit our enter. Notice something about this now, and this is another idiosyncrasy of the if-then statement. If I hit enter again, something didn't happen that you expected to happen. The countdown didn't get auto-declared, and this seems to be it's just an abnormality in the if-then statement. It's perfectly fine auto-declaring after the if. It has trouble auto-declaring after the else if and after the else statement also. So just be aware of that. And that may just be something that will be addressed in the next version of the software. It may not, may be that 3S isn't even aware of it at this point. But if we highlight countdown and we hit Shift F2, then we can get the auto-declare dialog box to come up. Again, it's not sure what kind of a variable it should be, and that's odd because just like up above, it should have known that it was a bool, but it doesn't. So that's part of that auto-declared dysfunction that seems to be based on the else if and the else part of an if statement, but you're aware of it. So, so now we've created a separate unique condition. Count up was one condition and count down is a unique condition after the else if. So we could just go ahead and copy this, and because now we say what we want it to do is we want it to subtract. So we want it to subtract 1. So that's the next level of behavior for an if statement, is to have two different conditions that are separate from one another. And yeah, so you say, what if we had count up make it count up, and not count up make it count down? Well, then we could have just said if count up, then else count down. We wouldn't have had to say else if count up. We wouldn't have had to say if count up is true, then do this. If count up is false, do this. We could have just said if count up, then do this, else do this, because that's the only two things that count could have been. All right, so Now let's go ahead and save that, and that's the second level of a if statement. Well, there is certainly a third part to an if statement, so we could come down and add that third part by doing enter. And now we could do an else statement. So we'll just come in, type EL, and right away it knows that that's probably what we're after. The autocomplete helps us. We go enter. Now what we've done is we've said, you know, if you don't see count up and you don't see count down, then do this. Well, either we're counting up or we're not counting up or we're counting down. We could do something basic like say else count shall be equal to count, but let's just do something different. Let's set a flag. Okay, so flag shall be equal to true. Okay, so and then we hit enter. So what that's saying is, okay, the first part of this told me that if you're counting up, go ahead and, if you see count up, go ahead and count up. If you see count down, count down. And if you're not doing either of those actions, set a flag that tells me that. Well, that seems pretty basic, but there's another thing we have to think about. If sometime we come through and evaluate this and we're not counting up and we're not counting down, we'll set this flag to true. How will we ever get it reset? Well, we're going to have to take that. And notice too that the auto declare didn't pick up on that flag. Again, I said under the else if and the else, it has trouble picking up on that flag. So what we can do is we can say, well, I'll tell you what resets the flag, doing either of these operations. So I'll copy this, come up here, tab, and say V. Now this is interesting because I'm going to change this to false. And look what happens when I click here. It says, oh, I recognize that this has not yet been declared, because now I'm up under the if statement. It doesn't seem to have the same difficulty as the else if and else does in terms of auto declaration. So it recognizes too that this is a Boolean. And so we say, okay. And it went ahead and declared the flag as a Boolean. I'm going to give it a little more space here. I'm going to copy that one and say, paste that down here. So now that's the completion. We can save this. That's the completion of our statement. It says if you see count up, go ahead and count. If you see count down, go ahead and decrement. And in either case, turn off this flag. But if you're not doing either of these, you'll fail this condition, you'll fail this condition, you'll come down and execute this condition. So this is going to, when we demonstrate this, it's going to demonstrate the order of evaluation of these if statements, because when we do an if statement, we evaluate the first condition. If it's not true, we jump down to the next condition. If it's not true, we go to the next condition, et cetera, until if all of those are, if they all fail to evaluate true, then we'll come to the if statement. There's no evaluation here. It's not saying else if this, it's just saying else, you know what? None of these were true up above, so just do this, okay? And again, that's completely optional. You don't have to do anything if you fail all those others. You may not have anything else that you do if you fail those others. You may just go to the end if statement and jump back out of here. If one of these is true, so if count up had been a 1 or had been true, then you would execute the 2 instructions associated in this case with that first condition. Once you completed those, you would jump directly to the end if, and you would completely ignore the other conditions and other instructions in the if statement. We're going to see this when we demonstrate it, because we're going to hit a button that's going to have us counting up, and if while that's counting we hit count down, nothing's going to happen, because count down never even gets evaluated. As long as this is true, we execute this part of the logic and then keep jumping to the end if. We never even know that there's an else if condition. We never even know that there's an else statement. That's the order of execution and evaluation of an if statement. So let's see that next. Now, before we go online and demonstrate that this if statement does what we claim it will do, I want to look at one more thing. In our else if statement, we've said if count down is true, we want to count down. So both of these if conditions have been very obviously, very blatantly Boolean, okay, because count up is a bool and count down is a bool. What about the situation where we have more than one aspect to a condition? We say, well, what if I want this to be count down and something else? Well, one of the ways we could do that, let's say as this thing counts down, let's say we never want count to go negative. And so we say if you have count down and, so we can, I'll just go ahead and do a caps lock and count is greater than 0, then, so this is now a compound statement. It's saying if count down and count not 0, then go ahead and keep counting down. And once you get to, to 0, then don't go any further. Don't create a negative number. So this can be as complex as we desire it to be in terms of the if condition, any if condition. There's only one inviolate rule, and that is that it must, at the end of the day, evaluate to a Boolean true or false. So it doesn't matter how many components to that condition exist, the condition itself must ultimately evaluate either true or false. Otherwise, it's an invalid if condition. So that finishes that off. Let's go ahead and do an F11 to build this. And we'll see that we have 0 errors, 0 warnings. We can close that. Let's make sure that on the devices we can scan for a runtime that's online, and it is this one. So we'll say OK, and then we'll tell it to, we'll save the project first, and then we'll tell it to download to that resource, and we download it. Let's go back to, we'll close the device, go back to PLC PRG, and now we're online with PLC PRG. Now, as I mentioned, we have created a little visualization for this. So if we come here to visualization, we click on HMI, that'll open up, and there it is right there. We can go ahead and get rid of its properties. Now we can put our, we can go to PLC PRG, and we can put our HMI by dragging it. We can put it out here on the side. Let's go ahead and get rid of our devices window so that we can see everything. So there we go. We see count, which is right here, and now we'll go ahead and count. It already has a value. If we wanted to, we could clear that out, but we'll go ahead and we'll count up, and you'll see count going up every 500 milliseconds. If we go count down, watch, if we push the count down button, count is still going up. And that's because since we get to count up and it's true, we'll do the count up instruction, and then we'll jump to the end if statement. We'll never even see that there's logic surrounding the count down button. Now, if we turn off the count up button and then we hold down the count down button, now you see that it's going down. So now it's decrementing. The other thing you'll notice that as soon as I let go of the count down button, I get this flag comes back up. This if example flag is being driven by this flag right here that we said, if I'm not counting up and I'm not counting down, then I want that flag to be true. If I'm doing either one of these, watch that flag, it's going to go false. And that's because of the, in either one of those, the if statement and the else if, I've got a instruction that tells that flag to be off. So now we'll test and see if our compound logic, which was that count down being true and count being less than or being greater than 0 works. Sorry, I let this get up that high. But now we're coming down, we're under 10, 9, 8, 7, 6, 5, 4. When we get to 0, boom, it stops. And even though we're holding the countdown button, and so that condition is true, notice that the flag doesn't go false. And that's because the second half of that condition, which is count is greater than 0, is not true. And so we come to count up, that's false because we're not holding the count up button. We come to count down and count equals 0, that's false, or greater than 0, that's false because count is equal to 0. And the else statement then says to turn on the flag, which is right here, and we don't do anymore. So we count up, 1, 2, 3, 4, and then we count down, As long as we're counting up or counting down, you notice that the flag is off. And if we're not doing either one, the flag is on. So that demonstrates, you can play with that. You have an example of it available to you. You can build your own if examples. This is a demonstration of the simple if-then statement using all of its components: if, else, and end if. This lesson will look specifically at the structured text syntax for a case statement. A case instruction is processed according to the following model. The test variable can have any valid identifier, but must be of the integer data type. This can be a signed or unsigned short integer, integer, double integer, or long integer. The case value label must be either a literal or symbolic integer constant. It cannot be a variable. Duplicate cases are not allowed. If the variable used as the test variable has the value 1, then instruction 1 will be executed. If test variable has none of the indicated values, then the else instructions will be executed. If the same instruction is to be executed for several values of test variable, then one can write these values one after the other, separated by commas, and thereby condition the common execution. If the same instruction is to be executed for a value range of a variable, one can write the initial value and the end value separated by 2 dots. Thus, in this example, test variable values 8 through 12 inclusive will all execute instruction set 4. To the right of this slide is an example of a case statement that looks at the value of an integer variable, myInteger, and encodes it in a set of 3 LEDs. Notice the syntax of the case label, which is a constant followed by a colon. Next comes the instruction or instructions to be executed in each case. In this example, the lines in gray have been compressed to optimize the presentation of the case concept. We'll look at this example in the demo to follow. The following video demonstrates the case statement. First, we'll look at the coding of the simple binary encoder sample just presented. Then we take a look at an example of a case statement being used as a recipe selector. To demonstrate the case statement syntax, I've created a small project here, case binary encoder. What this does is allows you to input a integer value from 0 to 10 to a variable called myInteger, and then it encodes the first 7 values, 0 through 7, first 8 values, in a 3-part digital encoder. So there's an HMI that goes along with that. We'll save that for later when we demonstrate it. But as always, single device, single application, single POU, PLC_PRG that's written in structured text and is over here to the right and is currently empty. Now, to do the case statement, as in anything else, I could start by declaring my variables. I want to demonstrate a bit about the auto declaration in here as I did with the if statement. So I'm going to just start by creating my case statement. As soon as I type C, the software tries to help me, comes up with case. So I hit enter and say that's good. So in case of, and I'm going to create a variable myInteger. So in case of myInteger of, having a value of, so I type in of, and notice that it tries to pick an OR statement for me, and I don't want that, so I'm going to click up here. And then when I hit enter, it recognizes 2 things. Number 1, it recognizes that I'm trying to create a case statement, so it gives me the end case syntax for that case statement, and also recognizes that there's been no previous declaration of myInteger. So it's going to create that by default as a variable in the current program organization unit, an internal variable. But I could have created it just as easily as a global variable, but I'm not going to. So we're going to leave it as a var. And notice that it was smart enough to know that the condition variable for a case statement has to be an integer, because the case statements evaluate an integer value. So it chose that data type, which is correct for myInteger. Now myInteger is being declared. I'm going to come up here and leave a space up above and we'll see why that is in a minute. I'm going to come down here. I'm going to just tab one time here, and you'll also see why that is. So the case condition is looking at the various values of the case condition my integer, and those are all integer values. So the first one I'm going to select is 1, and so the syntax is the case value followed by a colon, and then I'm going to go ahead and tab this. So if my integer is equal to 1, what do I want to have happen? Well, I have 3 outputs, output 1, output 2, output 3. They haven't been created yet, and I did that on purpose to show you that there's also a bit of a idiosyncrasy in the auto declare behavior when I'm in a case statement, as there was when I'm in an if statement when I got to the else if part. So if I type output 1, and then I say that output 1 shall be equal to true. So I just type in true, and then my semicolon. When I hit the return, you would expect the auto declare to pick up on the fact that that one had not been auto declared, but it didn't. Interestingly enough, when I tab in here and I do output 2, which is my next variable, and then I say that shall be equal to false in this case, and semicolon, and now when I do a return, it does pick up on that. So this is just a syntactical idiosyncrasy for the precompiler when it's following this 1 colon, when it's following the case condition selection, then it doesn't auto-declare the variable. But I'm going to go ahead and let it auto-declare output 2, which is a bool. That's appropriate. And I say OK. And then I'm going to just come up here. That's why I left the space. And I'm just going to go ahead. Actually, what I could do is I could go ahead and tell it to build at this point by doing an F11. And it's going to complain that it has an unknown variable. Okay. And so identifier output 1 is not identified. It's not defined. And so once that's highlighted, I can simply do a shift F2, and that will invoke the auto declare dialog box, come up here and say, okay, output 1 is a bool. That's correct. Then I can just come up here and do Control X and Control V and put that in the correct place. All right. Or I could have just gone up and typed it up there. So the final step of this is I want to come down. I want to declare a third output, output 3, and that shall be equal to false as well. Okay, and the auto declare comes up and declares that third variable. So that's the simplest way to put this case statement, is that I say if my integer has a value of 1, then go ahead and turn on the first input of my encoder and turn off the other 2. And then that's it. There's no other obligatory syntax for this case statement. I have given it a examination of my integer and given it one value that I'm interested in this case 1, and I've given it what to do in the case that is the case for my integer. Well, that's not a very valuable case statement, so we're going to do some additional logic here next. Okay, we're going to continue with this example, and what we're doing, we said, is we have an encoder that's going to encode the numbers 1 through 7, or actually 0 through 7. We'll see how we handle that. And I'm going to paste some logic that I've done from offline. And this is, just come in and indent all of this. Okay, so this is pretty straightforward. It's just a repetition of the logic earlier in terms of manipulating three outputs, output 1, output 2, output 3, but the manipulation is based on the individual values of my integer so that those values get encoded into the 3-bit digital encoder. Notice that in some cases I've chosen to use the word false, and in other cases the identity 0. Some places I've decided to use true, and other places I've used 1. So that's perfectly legitimate in terms of assignments for a Boolean data type. So now what I've done is I've essentially told it, if it's 1, do this, if it's 2, do this, if it's 3, etc. All the way down to 7, where I have turned on all of the outputs, which is appropriate. But the way I've set this up through the HMI is I've allowed the user to put in values ranging from 0 to 10. So how do I handle those values, 0, 8, 9, and 10? Well, that's where the else statement comes in. So I can come in and, let me just set it up here, come in and do an else, and right away the autocomplete picks up on what I'm trying to do. Come down, enter, tab, and now I want these same outputs. I can just come up here and copy them. Actually be easier if I go up and copy these, and you'll see why in a second. So I copy them, come down here below my else and say paste. And the reason I did that is because now I only have to change one of these values. So now if none of these conditions is met, 1 through 7 as the case for my integer, then I'll come down through these one at a time. Is it 1? No. Is it 2? No. Is it 3? Etc. etc. If I get and haven't satisfied any of these, once I satisfy one, then I'm good to go, and I go to the NK statement. But if I haven't, I come to the else statement and execute the instructions in the else statement, which are in this case to turn all 3 outputs off. So again, we can come up and do a build, and we see that we have 0 errors, 0 warnings. And let's see if this works the way we expect it to now. So we're going to go ahead and we'll look at the visualization, which is a HMI that's very simple. I just have 3 lights, most significant bit, least significant bit. This is a little different than something we've seen before. I have a slider that is valued from 0 through 10, and that's going to set the value for my integer, and I'm going to be able to monitor the value for my integer in this window here. So let's go ahead and close the toolbox and properties for the visualization. We'll come to our device, scan the network, tell it we want this runtime so that we're set up to go online, and then we'll close the device, and we'll take the HMI and slide it over here next to the logic, and we'll go online, see how this works. Let's give ourselves some more real estate by getting rid of our devices window. And I'm going to go ahead and hide the variables as well, the variable declaration section. There's no reason for us to be monitoring those. So there we see the entire case statement, and we see our HMI. So let's go ahead and go online. We'll save it first just for posterity. And now we'll go online. Alrighty. And now we see that none of the outputs are on as we begin. And now we look at my integer is equal to 10. That's because it was left over there in that position. So now when it's 0 with the slider, we see that my integer is 0. That doesn't satisfy any of these, so it satisfies the else statement, and we set all of the bits off. If we come here and put the value to 1, then we meet this condition, and we go ahead and make the first output true and the other 2 outputs false. So it works, and we can come up through all of the values that can be encoded by this encoder all the way up to 7. And then as soon as we go to 8, my integer of 8, we see that we're back to executing the else statement. So that's an example of a case statement. One of the things that I need to point out is don't get the impression that the instructions have to be the same. It's just that we have different my_integer values. Every one of these instructions could have been completely different from the previous set of instructions based on the case. And so this is just an example, and we'll look at an example next for recipe management that does the same thing. It changes a number of variables, but the variables are always the same for each case, but that need not be the situation. And so just be aware of that. Okay, so we'll go offline with this. Go ahead and save it. And that's our first example of a case statement. I want to come back to our binary encoder just one more time to make an additional point that was talked about during the slide presentation, but it hasn't been demonstrated yet. Remember that we knew what we wanted to do with values 1 through 7 for my_integer. And then we used an else statement to deal with the other values, 0, 8, 9, and 10. Well, we could have done that a different way. We could have come in here, let's say instead of the else statement, turning off all lights in case there was anything other than 1 through 7, we could have made a statement similar to this. We could have said, if you have a case of 0, 8, 9, 10, okay? Then, okay, so this would have been essentially saying for any of these other situations, now we can come up here and we can do a build, rebuild, and we're going to get 0 errors, 0 warnings, because syntactically, there's absolutely nothing wrong with this. I said, if you get 1 through 7, do this. If you get 0, 8, 9, 10, comma separated syntax, then just turn the lights off. Well, that's fine until I throw it an 11 or a 12. And then you might ask, well, why doesn't it doesn't fit any of these, so wouldn't it just leave the lights off? Well, if that's the state they were in when it discovered that 11 or that 12, but what if it had been a 2 prior to that? Okay, when it came down through here, it turned on the middle light, and then the next time it encounters a 12, well, it doesn't have an option for dealing with 12, and so it's not going to just by default say, well, I don't have an option, so I'll turn them off. It's going to leave them in the last known state, which in this case was 2. So you may be perfectly deliberate about doing this and saying, well, in any of those cases, I want this to happen, and that may be right because you know that 11 and 12 will never be a case that will occur. Another way that you might have done this, if you weren't worried about 0, but you just wanted to cover 8, 9, and 10, is you could have said 8, ... 10, and then that would have been a statement that says, look, if you encounter any of the values 8, 9, or 10, integer values between and including these 2 parameters, then in that case, turn off all the lights. So we'll come up here and we'll do a build on that. And there again, we'll get 0 errors, 0 warnings, because it says, okay, syntactically, I'm also fine with that. Logically, again, it may not make much sense, because what if you get 11? What if you get 12? And we still haven't told it what to do with 0 in this case. So one other thing I want to demonstrate with this is, what if I had said 7? Okay, well, that's conflicting, because we tell it 7 here, and then we tell it, well, really, in this case, do this. So we're giving it conflicting information for 7. And so is it like ladder logic, where you just come down and you execute the last thing you evaluated? Well, no. The precompiler is not going to tolerate that. If we do a build here, it's going to tell us that we have case label duplication. And so you double click on that, and it's going to take it here and say, look, you've already told me what you want to do with this value, and now you're telling me something different. It's not going to tolerate that. It's an error, and it won't allow you to compile that. So if we switch that back to 8, go ahead and do a rebuild again. Then it says, okay, I got you. There's no case duplication in this example. So just wanted to point out those two different syntaxes for covering the else statement, and also wanted to show you what happens when you have a duplicate. So let's just go ahead and put our else statement back in here and delete that colon. And now we've gone back to the original case statement. It occurred to me that maybe I hadn't been sufficiently clear about what I meant when I said the case value label could not be a variable. This is the case value label. We know that the case condition, my integer, is going to have a value. It's going to have a case, and these are the different cases that we're examining. These are the integers that we say we'd like to see tested for my integer, which is the case condition. So I've created a test variable called test integer, which is initialized to a value of 2. And what I'm asking is, why couldn't I replace this constant of 2 by doing an F2 with the actual variable test integer, which I know has been initialized to a 2. So let me just go ahead and enter here and tab so that we see that. So why can't I just have a case value label like this? Because that's the same thing. I mean, test integer is equal to 2, but this way I could manipulate test integer to be equal to any number of integers, depending on other places in my project code. Well, let's test that. We'll go up and we'll build. And as soon as we do that, boom, we get the double red line and we get this statement. Case label requires literal or symbolic integer constant. So I had a symbolic integer constant there before. I had a 2, and it was perfectly happy with that. What happens if I come in and do a int #2? Okay, so I'll do int #2, and now this is a literal where I've literally told it this is 2 and it's going to be an integer. And then I can come up here and do a build again, and 0 errors, 0 warnings, because it recognizes that it is, just as we said, either a symbolic integer or it's a literal. So that's what I meant when I said that these case value labels could not be held by a variable. So that's the demonstration. Here's another example of how a case statement can be used in a project. This is a reaction vessel for, say, a pharmaceutical application, where we open a fill valve and we fill it with a certain amount of liquid, and then we turn on some heater bands on either side of it and heat it up to a certain temperature. Then we agitate it for a while at a certain agitation speed. While we cook it for a period of time, we may add acid or base to adjust its pH. The operator interface for this shows that there are a number of variables, of course, in this process that need to be controlled. We can control any of these directly from the operator panel. One of these would be the target vessel level, which we could click on that at any point and we'll get a way to put that from anywhere from 0 to 100% in terms of filling. Others of these, I'm going to go ahead and just increase the size on this enough so that they are a little easier for you to read. So we have a target vessel level and then the actual vessel level, and you notice that I can manipulate this one but not this one, because this is just a monitor. The target agitator speed, in other words, what speed am I looking for? What is the current agitator speed? How long should the agitator run? How long has it been running currently? Temperature. And we can actually set what should the initial temperature of the reaction vessel be? What is the target temperature during the reaction? What is the tolerance that tells me I'm within my temperature tolerance? How much of a band do I have there? And what is the actual current temperature? In addition, we can set the cook time, how long it's been cooking, what the initial pH of the reaction vessel should be, what the target pH and what its tolerance and the actual. So that's certainly, as I said, any one of these, you could set the initial temperature. Let me go back to my 90% here, which makes it a little bit easier for you to see all of this. So 90. And then we'll get back to where we're centered. So as I said, any one of these can be manipulated independently by entering the value, but that's not very practical unless we're only changing one thing. If we're changing several things from batch to batch, we also have this button over here called recipe number. And what that does when we click on it also gives us an option for picking one of 10 recipes. And so if we come and pick recipe 2 and say OK, all of these values will be adjusted and the system will be adjusted to be ready to start at new preset values. So our preset pH is all going to change. Our fill level will change if necessary. So how is this accomplished? Well, you know it's going to be accomplished through a case statement. So we'll go to the recipe manager and look at that, and we'll see that it is just one large case statement based on this case condition called recipe number. So let's go offline and take a look at that. So here is our recipe manager. It's a function block that gets called that's in structured text. And it's nothing but a huge case statement. Here's the recipe number variable, which is declared up here to be an integer. And then here are the cases for that integer, 0 through 5. And then we have an else that says, you know, if the recipe number is 0, that means stay with the current values in the recipe. So fill data set point shall be equal to fill data set point. So essentially make sure that nothing changes. But then each recipe has its own unique values for these. Now, the other thing to recognize is that here's fill data, here's agitation data, here's reaction vessel 1 overall data, heat data, ferment data. So there's a lot of different data types that have been created for this application that are being pulled together into one recipe. So we can manipulate a number of variables within the application coming from multiple different sources through a single button called the recipe number. And so that's the advantage also of a case statement, is that it can consolidate a number of variable values into one position where you can change the value of all of them through a recipe. So that's a demonstration of how a case statement can be used as a recipe manager. You can see this, say, in a packaging machine where you're going to change the size of the box, the number of items that are going to be put in the box, a number of different parameters about that particular machine could be changed with just one change of one number in the recipe. So that's another example of case statement. True or false? The conditions for an if statement can be very complex. The key is that in the end, they evaluate to a Boolean result. Which of the following statements is true regarding an if statement? Check all that apply. Select A or B in the white boxes of column 1 to match which parts of an if statement are required and which are optional. Which of the following statements is true regarding case logic behavior? Check all that apply. True or false? A case statement must not use a variable as a case value label. True or false? A case statement must include an else option to handle exceptions. This statement is false. The else option is optional in a case statement. True or false? The conditions for an if statement can be very complex. The key is that in the end, they evaluate to a Boolean result. This concludes the module on structured text conditional statements.